Hello. Today we're going to start on 1-3 in geometry, and that's measuring and constructing angles. And sorry to say we won't be really constructing angles yet, but I promise we'll get to it. So today, by the end of the video, you will be able to name and classify angles and measure and construct angles, and then angle bisectors we'll probably get to in class the next day. Okay, so for some vocabulary, an angle is formed by two rays that have a common vertex. So let's say here's one ray and here's another ray. This is the vertex, that's where they meet. So you could say it's where the angle begins, I guess. And an angle is formed by two rays. And if I wanted to talk about the interior of an angle, that's all this space inside. If I wanted to talk about the exterior, that's all this stuff outside of the angle. So this will be helpful when we're talking about some vocabulary. Okay, so the first thing that we're going to be doing is naming angles. There's three ways you can name angles. Excuse me. Okay, the first thing is, let's say we have this angle. Sorry, let's draw another angle. Let's call it point. Let's give it points A, B, and C. The first way you could do it is just call it angle B, because there's nothing else around it. We probably won't be using simplistic angles like this, but that's one way you could do it. Another one is to classify it by all 3 points. A, B, C is talking about all this space inside. And notice B is the vertex and B is in the center. A third way you can name an angle is sometimes I'll put little numbers in here, and so another way you could do it is angle 1. It's important that you make sure that there's no degrees there, so I can't call it angle 1 degrees. 1 degrees is how we measure angles. So as long as it doesn't have any degrees there, you can name it by that. Okay, but some angles, more angles that are going to be really complex, like this one, number 1. So I couldn't just say angle A. That doesn't give me enough information, because angle A could be talking about this part, it could be talking about this part, or it could talk about, we're just not sure. So angle A is not a good way. I want to talk about 3 of the angles. Okay, so there's lots of angles in this one. Let's say I wanted to talk about this part. Well, I'm going from B to A to C, so BAC is totally fine. Again, notice that the vertex is always in the center. If you wanted to name it angle cab, you're more than welcome to do that as well. So that's one. Now let's say I wanted to talk about, this is not going to erase. Perfect. Let's say I didn't want to talk about this yellow one anymore. Let's say I want to talk about this angle over here. Okay, well, some of you guys might guess it's going from C to A to D. CAD is entrapping this yellow stuff, so CAD works. Again, notice that the A, the vertex, is in the middle. Okay, it wants 3, so we've named 2 so far. I want to name one more. Let's say I wanted to talk about this whole thing, so both parts of the angles. Well, that's going from the ray with B on it to the ray with D on it. So angle bad is totally fine. Okay, so I want you to try to do number 2 on your own. Notice number 2, there's also numbers in here. So you could call angle 1 this part. You could call angle 2 this part. And then I want you to also give me use the letters to name it as well. Okay, so try that on your own. Okay, example number 2, measuring and classifying angles. We won't be actually using protractors a lot in this class, but there will be some activities where we will. When I ask for the measure of an angle, angles are always measured in degrees. Okay, so there's when I ask to classify angles, there's 3 types of angles. There's an acute angle. Here's an example of one what looks like. It's less than 90 degrees. So it's tiny. It's an acute little thing. Then there's also a right angle. A right angle is always exactly 90 degrees. And then the last type of angle is an obtuse angle. Obtuse is something that's larger than 90 degrees, but smaller than 180 degrees. So that's what this sentence means. It's bigger than 90, smaller than 180. Okay, so I'm going to do A and B, and then you guys are going to do C and D on your own. Okay, so we're going to use this protractor, and you're going to find out how big the angle is, and then actually is it an acute, a right, or obtuse. That's what I mean when I say classify. Okay, so angle X, Y, Z. I'm sorry, Y, X, Z. So I'm going to go to Y, I'm going to go to X, and I'm going to go to Z. So this is the angle I'm talking about. If you notice, you can look either at the numbers on top or the numbers on bottom. Either way, it doesn't make a difference. But notice this one, if I look just at the top numbers, it's going from 0 degrees to 50 degrees. So all you have to do is subtract. And in this case, it's going to be 50 degrees. So, question to think about, can you have negative angles? Not in geometry. So always, if you get a negative answer, just make it positive. Take the absolute value. And then since 50 degrees is smaller than 90 degrees, we're going to say that this is also an acute angle. And it looks like it. It looks like an acute little angle. Okay, next one. Let's go ahead and do letter B. Okay, so B says ZXY, ZXW. Okay, so we're going from Z, we're starting at Z, then we're going to X, then we're going to W. So we're talking about this angle right here. Again, it doesn't matter if you look at the top of your protractor or the bottom. I'm going to go ahead and look at the top. So it goes from 50 degrees to 150 degrees. So it doesn't matter the order, just subtract them. Make sure your answer is positive. So I have 100 degrees. That's how big the angle is. And since that's larger than 90 degrees, it's going to be an obtuse angle. Okay, so you're going to try C, D, and think about E. And then we'll talk about it in class. Okay, last thing we're going to do in the video. Example 3, using the angle addition postulate. This was very, very similar to the segment addition postulate that we learned in 1-2. Segment addition postulate said, well, if I know that this part of the segment is 1 and this part of the segment is 3, then the whole segment is going to be 4. Angle addition postulate is the same thing, except instead of segments, we're talking about angles. So for example, if I knew that this was 30 degrees and that this one was 10 degrees, well, if I add those up, that means that the whole thing has got to be 40 degrees. An abbreviation, because again, we use these in proofs, put a star by it. An abbreviation I like to use is angle. This is a symbol for angle. Sorry, I didn't tell you that sooner. Addition postulate. So in proofs, you can, instead of writing out angle addition postulate, you can write these symbols instead. Okay, so what we're going to be doing for number 4 and 5, and then you're going to go ahead and do 6 by yourself, is we're going to fill in what we know. So it says angle DEG. D to E to G, that's this whole thing. So this whole angle is 115 degrees. Then it says angle DEF. D to E to F. So that's this part right here is 48 degrees. And they want us to find FEG. So what is this part? Well, if you think about it, this plus this will equal this. So you could write an equation that looks like this. 48 degrees plus something will equal 115. Some of you guys are also thinking, well, can't you just subtract? Of course you can just subtract. So subtract 48 from both sides, and you're going to get that the angle, measure of angle FEG, that's what this M means, stands for measure, it's going to be 67 degrees. Okay, number 5, XWZ. XWZ, well, that's this whole thing, because we're going from X to W to Z. So that's this whole thing is going to be 121 degrees. And then XWY, XWY. So that's this part is 59 degrees. Okay, this one looks just like number 4. We don't know what this part is, so we can call it X. So if we take these two little pieces, 59 degrees plus X, it should equal the 121 degrees. Subtract the 59 from both sides, like we did in algebra last year. And you'll get that the measure of angle YWZ equals, let's see, 62 degrees? Boom. Okay, so some of you guys might be thinking with Broyles, and both of these we've subtracted, but you said it's the angle addition postulate. Sometimes you're going to be adding, sometimes you're going to be subtracting. It's either or. See what you have to do for number 6. So today we learned about 3 things. We learned about classifying angles, we learned about angle addition postulate, and we learned how to use a protractor. Tomorrow in class we'll talk about angle bisectors. Yeah, have fun.